Let's add on some complexity. Here we have 3 times e to the 5x equals 1977. We need to make sure that the exponential expression is by itself on one side of the equation. So the first step will be to divide by 3. And I don't know what 1977 divided by 3 is, so we're going to pull up our calculator, 659. And we get e to the power 5x equals 659. The e allows us to use natural log. Whatever we do to one side of the equation, we do it to the other. Natural log and e are inverses, so we can cancel them. 5x equals natural log 659. I want to solve for x, so I can divide by 5. And we have our exact answer. X is equal to natural log 659 divided by 5. To get our approximation, 659, apply the natural log. We want to make sure we have the correct log here, natural log, divided by 5. Gets us 1.298, and we have our exact and our approximate, and we can check e to the power, I'll put a parentheses, 5 times 1.298, yep, double checking that, close parentheses, equals 658 point something, that's really close to the 659. Multiply that answer by 3, 1975.57. It's a little off from the 1977, but not by a lot. And that really comes to just the rounding. It's a rounding error difference. Before multiplying by 3, we had 658.5. Notice that that's really close to 659. So when we multiply by 3, we're going to get a bigger error because we're multiplying that error by 3, that difference by 3. But that's okay. We got something close. That's what we wanted. I'll leave number 9 for you to work on your own. 1250 e to the power 0.055x equals 3,750. Let's take a look at the next one. 30 minus 1.4 to the power x equals 0. We could do this one of 2 ways. We can either subtract 30 from both sides and then divide by a -1 to get rid of the negative. I'm going to add 1.4 to the power x to both sides so that I don't have to worry about that negative sign. And now in this problem, just like the other ones, we could use log base 1.4. It's a little awkward. It's not wrong. It feels weird for me to use a decimal in my base for logs. So I'm just going to use any log. Instead of using the common log, base 10, I'm going to use log base e this time, natural log. So we'll do natural log 1.4 to the power x equals natural log 30. And then the natural log on the right side allows me to pull that exponent down. I want to solve for x, so I divide by natural log 1.4. And this is my exact answer, natural log 30 divided by natural log 1.4. If I want an approximation, natural log 30 divided by natural log 1.4, I get 10.108 for my approximation. And then if I want to check, we can check it. 30 minus 1.4 to the power 10.108, and we should get something close to 0, and we do, 0.004. That's really small. It's something really close to 0. It shows us that with the rounding, we get something really close. Let's see what happens if we have something even more complicated than just x, or x times a number, up in the exponent. Here we have e to the power 1 minus 8x equals 7,957. Since I have e, I'm going to use natural log on both sides. My exponential expression is by itself. E and natural log are inverses, so I can cancel them. I need to solve for x, so we could subtract 1 from both sides. And here's where we need to be really careful. This natural log 7957 is a number in and of itself. If I subtract 1 from that number, I don't know what that number is. Natural log 7,957, I have no idea what that number is. So I cannot do anything to combine them together. I have to leave the -1 out. It will not equal natural log 7956. That's my ultimate point. It's a common mistake when you're first learning to solve equations with exponents in them. And then I can divide by -8, divide the whole thing by -8. X equals -1 plus natural log 7957 divided by -8. We can multiply everything by -1. 1 minus natural log 7957 divided by +8. These are equivalent, So if you were to move things around differently, you would get one of these two answers. I'm okay with either one. But I'm going to let this one be my exact. It's a little bit simpler in order to plug it into my calculator. I'll use a big parentheses, 1 minus 7957 natural log, and I'm going to divide by 8, and I get negative 0.998 for my approximate, and I can use that to check. So e to the power 1 minus 8 times 0.998 negative 0.998, and then I hit equals 7,974. Let's double check and make sure we did that right. 1 minus natural log 7957 equals that. Divide by 8, negative 0.998. Okay, and then e to the power 1 minus 8 times 0.998 negative 7,974. We're not quite the same value, 7957, 7974. We're off by a lot, which is concerning, but I'm going to try this one more time, and this time I'm going to use the whole number and see if that will help mitigate the rounding. So 1 minus 7957, take the natural log, equals, divide by 8, equals, I have that whole thing, e to the power, parentheses, 1 minus 8 times, big parentheses, 1 minus 7957 natural log, divide by 8. There's my 7,957. So instead of putting in the rounded negative 0.998, I put in that whole exact expression, and I got what was in my equation. It's pretty complicated. The bigger the number with the smaller base, I mean, e is a base of 2.718, which is pretty small. So when I round even just to 3 decimal places, and I try to get e to a power to be a really big number, I'm really increasing that rounding error that I have when I'm solving. Use your best judgment as far as close or far away. If you think you got it right, but your answer is really far away, also consider the differences in the size of these numbers, the base and the answer. Because if they're really different, like this one, 2.7 and 7,957, your error is going to be much bigger. Try the next one on your own. 5 to the power x minus 3 equals 137. In our upcoming lessons, we'll look at applications of exponential equations, and then we'll also look at solving logarithmic equations.